Welcome to Think Global Education Services. Today's topic is moment of a force and torque of a couple. So let us say we have a ruler. This is a ruler. Let us say this ruler is 1 meter in length. And the mass of the ruler is distributed uniformly along the length of the ruler. So we can say that at this point, this is the 50 centimeter. So at this point, we have the center of the mass, the ruler. The center of the mass acts at this point. So we can mark the center of mass as Cm. Now, here in case, if I applied a force, let us say I apply the force in the center of the mass. Apply the force here. Apply the force here. Then what I can expect is that I can expect the entire ruler to translate to a new position. So when I apply a force at the center of the mass, the entire ruler translates. Now, if I applied this same force somewhere away at a distance of d from the center of mass, so this is the distance of d from the center of mass, and I apply a force here, then, and also I can fix this center of mass by putting a nail here and hitting the ruler with a nail. I can fix the center of mass, and if I apply the force at a distance of d from the center of mass, then I can expect the ruler to turn in this direction. So it is going to turn anti-clockwise. So here what I have done is I have introduced a force which is perpendicular to the axis of rotation. So axis of rotation is the line from the center of mass through this point where the force acts, and this is the axis which is going to rotate when I apply the force. So that's why it's called as the axis of rotation. And using this terminology, we can find out what is the moment of the force here which I applied. So moment of a force, we can represent that as moment is equal to the force applied multiplied by the perpendicular distance of the pivot. So here I have nailed the center of mass, so I can call this as the pivot from the line of action of force. So this is the line of action of force. Force is acting in this line, and the perpendicular distance is, this is the perpendicular distance from the line of action of force to the pivot. So I calculate the distance, so that distance is d. So I can get the moment is equal to force multiplied by the perpendicular distance from the line of action of force to the pivot. And here we can get the units for moment. Unit of force is Newton, and unit of distance is meter. So Newton meter is the force of moment. Now in case if we have two or more forces, let us say we have, this is a force F1, and here is another force, this is F2, and it is at a distance of d2 from the pivot. So I can calculate the moment due to F2, which would be moment due to F2, which is equal to F2 multiplied by d2. So I can equate these two moments and find out what will happen to the ruler by equating these moments. In case if these moments are both equal, then the object will not move anywhere, because here, due to F2, the object will tend to move clockwise. And if the clockwise moment is equal to the anti-clockwise moment, the clockwise moment is equal to the anti-clockwise moment, then the object will be in equilibrium. It will no longer move. So if the clockwise moments is equal to anti-clockwise moments, then the object will be in equilibrium. So using this, we can introduce a principle that is called as the principle of moments. So principle of moment is, for any object, you can take a ruler or any other object that is in equilibrium, that means in case the clockwise moment and anti-clockwise moments are equal, so that means the object is not moving, the sum of clockwise moments about any point provided by the force acting on that object equals the sum of anti-clockwise moments about the same point. So that means if the object is in equilibrium, then the sum of clockwise moments is equal to sum of anti-clockwise moments. So using this principle, we can find out unknown forces. In case of an object is in equilibrium, we can find out the unknown forces on the object, and we can find out the distance at which the force acts. So these are the applications of principle of moments. Now we can discuss about the torque of a couple. So first we can discuss about a couple. So as the word suggests, couple means two. So two is nothing but two forces here. So let us take a steering wheel of a car, which would be circular. And we'll have something to hold our hands in the middle. Let's consider this is the steering wheel of a car. And this is the center of mass of the steering wheel. Now, if I were to keep my hands in this position and I apply a force upward here, at the same time I'm keeping the hands here and I'm applying a force in this direction, then what I can expect is that I can expect the steering wheel to rotate. Maybe it may rotate like this. So it is rotating in an clockwise direction. It is rotating clockwise. So here what I have applied is I have applied a couple of forces. Which are equal in magnitude and parallel, opposite in direction. As you can see from the image I have drawn, this force, let us say this force is F1. F1 is going down and F2 is going up. So they are opposite in direction, and as you can see, they are both parallel. And they are separated by a distance, let us say, we can call that a distance as D. They're separated by a distance D. And they are both parallel, and you can say they are both equal in magnitude. Then what I can expect is that they will produce a rotation, but there will be no acceleration. Since both the forces are equal, there will be no acceleration, there will only be rotation. That's what we can expect here when we apply a couple of forces. Now here, what I can do is that I can calculate what is the amount of rotation. That amount of rotation is called as the torque. So torque of a couple is nothing but the amount of rotation when I apply a couple of forces. So the torque of a couple is measured by, you can write the torque as the letter tau. This tau is equal to one of the forces. You can write it as one of the forces F multiplied by the distance between the two forces. Distance between the two forces. This is the torque of a couple. Now, in the moment of a couple also, we got distance, force multiplied by distance, but that is the perpendicular distance from the pivot and the line of action of force. That is perpendicular distance between the pivot and the line of action of force. So we have two different types of moments. One is a moment of a force and one is the torque of a couple, and they both produce a rotation, that is the motion, they both produce this rotation, but they are both different. In case of moment, we have the rotation about the axis. Now in case of a torque, we have two forces which are called as a couple. They are equal in magnitude, parallel and opposite in direction. They produce a rotation without acceleration. Now we can also calculate power of this rotation. What is the power due to the force? So when we have a force, we can calculate, when you have force and we move an object, we can calculate the work done or energy. From energy, we can calculate power. Likewise, here also, we can calculate the rotational power of an object which is moving. So rotational power. So I can rewrite the power. Yes. Rotational power is, as we know, force multiplied by the distance. As it is rotating, we can write the distance as circumference divided by time. From here, we can write that as F multiplied by R. So R would be the distance. So as you can see, force multiplied by distance would be tau. So this quantity will become tau multiplied by 2 pi divided by T. So it is tau multiplied by 2 pi divided by T. Now it is tau multiplied by 2 pi and 1 by T. 1 by T is equal to omega. And omega is the number of revolutions due to the torque which we apply. So that is tau 2 pi omega is the power. That is called as the rotational power due to a torque. Now we can calculate some problems based upon moments. So let us take again a ruler, or we can take it as a seesaw. We can take a seesaw. Seesaw is also kind of like a ruler. So here, the same principle also applies here. So what we can do is that we can put a pivot here. This is the pivot, and this is the seesaw. And here I'm going to apply a force. And now instead of force, since it's the seesaw, we can apply weight. So the mass of this object is, let us say, 10 kilograms. So the weight would be 10 multiplied by 10, which is equal to 100 Newton. So this 10 is the mass. This 10 is the acceleration due to gravity g. So I'm taking g to be approximately equal to 10 meter per second square. So then my weight would be equal to, the weight which I apply here would be equal to 100 newtons. Now on the other side, I can apply this another weight. Now this weight, I can take, this is the center of this mass of this weight, and is the pivot, and the distance between the pivot and the line of action of the force, that is line of action of weight, is, just take this, would be equal to 10 centimeters. Similarly, I apply another force here. This force is again another weight. This weight is equal to 12 kilograms. So that would be equal to, that is also going down. So that is 120 kilo, that is newtons. And here, I want to find out the distance here. If I want to find out the distance, then I have to equate the clockwise moments is equal to anti-clockwise moments. And as we can see, due to this force, the object must move in this direction. Will tend to move in that direction. Now, due to the 120 newtons, the object will tend to move in this direction. So you can see that this is clockwise, and this is anti-clockwise. So now equate that 100 newtons multiplied by the distance is 10 centimeters. So I have to convert it into meters. So 10 multiplied by 10 to the power minus 2 meters, which should be equal to 20 newtons. That is 120 newtons. Here it is 120. Since it is 12 kilograms, it is 120 newtons multiplied by distance d. So now if I calculate that, so here I'll get 1 by 10, so that I'll get 10 divided by 120 is equal to d. So I'll get 1 by 12. So d is equal to 1 by 12 meters. So we can calculate the distance. Now in case if I have the distance somewhere, let's say the same problem, I'm going to remove this weight. I do not know the weight, I want to calculate the weight, and if I gave you the distance here as, let us say, 20 centimeters, then I can find out the force which will be required to make the system come to rest. That is, if the system is at equilibrium, then I can find out the force here. Assuming that the system is in equilibrium, so we're going to find out the force. So here, as we know, 1 by 10 meters, which is equal to 20 into 10 to the power minus 2 multiplied by force F. So F is equal to 100 divided by 200 multiplied by 10 to the power minus 2. So it should be equal to 100 divided by 2, which must be equal to 50 newtons. So that is our answer. This is how we can work out a force, moment of a force, and torque of a couple. And thank you for watching.